Okay, so today's lesson is going to be fairly short. It's very similar to a previous lesson. So we're just going to talk about factoring when you can take out a common factor before you actually factor the equation. So we already learned this for an instance like this, where we have 6x squared plus 3x plus 36. This is something that we could factor out a number before we actually factor the equation. So in this case, all three terms are divisible by the number 3. So we could take out a 3 from every single term and then factor the whole thing after that. So this would become 2x squared plus 1x, or just x, plus 12. So I took out a factor of 3 from all of my terms, and then I could just factor this whole second thing normally and keep that 3 on the outside. So the same thing can happen where we have a more complicated factor in an equation. So let's look at this example. So let's look at an equation like this. I have 3 terms, but it is kind of messy. We have a bunch of things in the first term, a bunch of things in the middle, and a bunch of things in the last term. So this isn't really in a format that we would be able to factor right now. This would be kind of confusing. There's a lot of variables in there. But if I look at all 3 sections, I actually do have something that's in common. You can see I have an a plus b here, I have an a plus b here, and an a plus b here. So look back at the title of the lesson, factors that are sums. So we have a sum in parentheses, and that happens in every single term, so we can actually factor out that sum before we even start factoring the whole equation. So we're going to take out that full term, the full a plus b, from every single term. So if I take out the a plus b, I'm left with an x squared, an x, and a 6. And now I've made it a lot less messy, and now this is in a format that we can actually do something with. So I'm just going to walk through this with you. For now, we're just going to ignore the a plus b on the left, and we'll just throw it back in later. And we're only going to deal with this right here, this equation that is in the format that we need it to be so that we can factor it. So I'm going to find the factors of -6 that add up to -1. And I'll write those over here. So we could have -6 and 1. We could have 6 and -1. We could have -3 and 2. We could have 3 and -2. And that's it. So now I have to figure out which one of these pairs adds up to a -1. And that would be this one right here, the -3 and 2, because -3 plus 2 is -1. So now that I know my factors, I can plug those back in over here. So I write my 2 parentheses. I know that my factors are -3 and a +2. And then I just cannot forget this thing, so I'm going to drag that right down here and make it a plus b again. So let me rewrite my final answer. I have an a plus b in parentheses, I have an x minus 3, and I have an x plus 2. And that would be my final answer. Okay, so this equation has even more going on than the last one. We have a lot of variables here, and I'm just going to go through every single term and highlight all the things that they all have in common. So the first one has an m, the second one has an m, and the third one has an m. And because they all have that same thing, I can actually take it out of all of them. So I'll write that over here. I got rid of that m. Now let's see what other factors they all have in common. This one has an x minus 1, this one has an x minus 1, and this one has an x minus 1. So m times x minus 1 can actually be taken out of every single term. And let's look again. So this one has an x, this one has an x, but this one does not have another x. So I cannot take an x out of all of them. It has to happen in every single term. Let's look at those leading coefficients. We have a 7 here, and we have a 10 here. There's no common factors of 7 and 10 except for 1. So I can't take anything out of those. I could take a 1 out of everything, but that wouldn't really do anything. I could put a 1 over here, but it doesn't change that at all. So I took out the m times x minus 1, and let me just write what I'm left with. So in my first term, I still have an x squared, In my second term, I have a 7 and an x, so I can say plus 7x. And in my last term, I have a 10, so plus 10. And now I have set this up so that I can factor this whole thing right here. And I'll just ignore the things on the left that I factored out, but I'll make sure that I put them there in my final answer. So I'm going to factor this like normal, find the factors of positive 10 that add up to positive 7. Let me write those over here. So we could do 10 and 1, we could do 5 and 2, that's it. And I know that 5 plus 2 is 7, so my factors here are going to be a positive 5 and a positive 2. And I can't forget that thing that I have on the outside, so I have my m times x minus 1. And this whole thing is my final answer.